In this video, we look at some examples of limits using the fact that the limit as theta tends to 0 of sine of theta over theta is 1. Alright, so example number 1, we have the limit as theta tends to 0 of tangent theta over theta. We can, of course, rewrite the tangent of theta as sine theta over cosine theta. And then we need to divide all of this, which is equal to tangent of theta, by theta, or theta over 1. But instead of dividing by theta over 1, let's multiply by the reciprocal of theta over 1, which is 1 over theta. And now we can rearrange this so that we get the limit as theta tends to 0 of the sine of theta over theta times 1 over cosine theta. Now, we have a limit of a product of two functions, sine theta over theta and 1 over cosine theta. You may remember that what we can do is think of this as two limits. We can rewrite this as the limit of sine theta over theta times the limit of 1 over cosine theta. The first limit is 1, as we have seen, and then to evaluate the second limit, all we have to do is substitute in 0 for theta, and we get 1 over the cosine of 0. The cosine of 0 is 1, so we get 1 over 1, which is 1, and 1 times 1 is 1. Alright, let's go down to the second one. We've got the limit as x tends to 1/2 of the sine of 2x minus 1 over 2x minus 1. Well, this one does not really look like the limit that we've just been talking about, at least not yet. Notice that what's happening is that as x tends to 1/2, 2x minus 1 is tending to 0. And you've got the same thing here as you do here. What we can do is make a substitution. We can let theta be 2x minus 1. Alright, so I'm going to rewrite this limit. And I'm not going to write x tends to 1/2. I'm going to hold off on that part for just a moment. But I'm going to replace the 2x minus 1 with theta in the numerator and the denominator. And now let's think about what's happening. As x tends to 1/2, what does theta tend to? Well, if you substitute in 1/2 for x, you get 0. So we could write the limit as x tends to 1/2, but that really sort of evades what's going on. It's better to write theta tends to 0, and now we get the limit that we already know. So basically, here's the way I think of this. If I've got the limit of sine of some expression over that same expression, and again, that these two expressions have to be identical. They have to be identical and they have to go to 0. And if that happens, then what we've got is equivalent to the limit as theta tends to 0 of sine theta over theta, and so the answer is, the limit is just 1. More on that in just a moment. Alright, let's go down to number 3. We've got the limit as theta tends to 0 of sine theta over 3 theta. Well, that looks a lot like what we've got up here. It looks very much like this limit, except there's this 3 in the way. Well, how can we handle that? Well, I'm going to rewrite this as 1/3 times the sine of theta over theta. And now this is a constant. This 1/3 is a constant. You might remember that if we have a constant factor, we can pull that outside the limit. And so what we can do is rewrite this as 1/3 times the limit as theta tends to 0 of the sine of theta over theta. This limit is 1. And so the answer is 1/3. All right. A fourth example. We've got the limit as theta tends to 0 of sine of 3 theta over theta. So you may be thinking, well, let's do sort of what we did before. Let's think of this as the limit as theta tends to 0 of 3 times the sine of theta over theta, and then we can pull the 3 out. But there's just one problem with this. Sine of 3 theta is not equal to 3 sine theta. So let's not do that. Instead of making this expression match this expression, instead of making the 3 theta match the denominator, let's make the denominator match the expression that we're taking the sine of. So in other words, what we need is a 3 theta here. Alright, so let's do the following. I want these two to match. That's great. Now we've got the sine of an expression over that same expression, and as theta tends to 0, 3 theta tends to 0. So that's going to be 1. But we have changed the problem. We've introduced a 3 into the into the denominator. So we need to compensate for this 3 in the denominator that we just added. We can do that by putting a 3 in the numerator. In effect, what we've really done is just multiplied the original expression by 3 over 3, which is 1. Alright, now, this 3 we don't really need on the inside, so I'm going to move it to the outside. And now you can either do a substitution like we did up here in example 2, or you can just note what we said before. If you've got the limit of the sine of some expression over that same expression, and that expression is tending to 0, that the limit is 1. And don't forget the 3 out in front. And so our answer is 3.